Hello and welcome to 8.2. I'm sorry, I forgot my picture. That's all right. And today, 8.2, 8.3, and 8.4 are almost all the same. 8.2 is about a proportion, 8.3 is about a mean, and 8.4 is about the standard deviation. They all have the same steps. It's just what you're testing where to figure out what you're doing. So 8.2 starts out with a proportion. So we're starting here. We're going to test a claim about a population proportion. And our notation stays the same, nothing's different here. We have NP, P hat, and Q. Our requirements are pretty close. We have to have a simple random sample. Our binomial distribution must be met, so it's got to be fixed, independent, 2 categories, and the probability of success has to remain the same. The condition of NP is greater than 5 and NQ is greater than 5. So how many you're having times your percentage has to be greater than 5. So I have to have more. I have to have 5 or more that are correct and 5 or more that are no. So your yes or no, your 2 different options. We have a formula for calculating Z. We will be using StatDisk to find this, along with the p-value and the critical value. But if you're at home, you can use this here to find your Z-score. You do not have to use StatDisk, but it is possible. We're going to do confidence intervals to figure out how confident we are that our population proportion is in the same. We will also be using the p-value method and the critical value. We will be doing both for testing a claim, not just the p-value. All right, let's get going on our example here. We're going to start out with 1,009 consumers and ask them if they are comfortable with having drones deliver their purchases. And 54%, or 540 of them, responded with no. We're going to use these results to test the claim, so this is what we're going to test, that the consumers are uncomfortable with drone deliveries. The most refers to 50% or more. All right, so we got to check our requirements. And is it a random sample? The answer is yes. Now we have to check our binomial. So we have a fixed number. They're independent trials. We have 2 categories, and the number 50% and 50% stays the same, so all 4 are met. The requirement of NP is greater than 5, so we have to take the 1,009 times our 50%, that's down here, and we get a 504, which is definitely greater than 5, and so is NQ since they are both 50%. So all requirements are met, we can actually do our calculations. All right, first we're going to start with a p-value method. All right, the p-value method is, we're going to do StatDisk. The significance level, if it's not given to you, we're going to use 0.05. Now, what this actually does is gives you a 90% confidence interval. And the reason that is the 0.05 is on both tails, is what these are called. So there's 0.05 here and 0.05 here, which gives you a 90% in the middle for our confidence interval. Our null hypothesis, remember, is the one that has the equal, and our alternative is the one without the equal. So what is the null hypothesis for our statement? And our alternative is we want to say that P is greater than 5, right? So if this is P is greater than 50%, then our null has to be P is equal to 50%. To get our most. That's where that came from. All right, so we're going to test our hypothesis. So you're going to go into your analysis, and you're going to do a hypothesis testing. So you're in analysis. Okay, sorry about that. So make sure you're going to hit an analyze. And then you're going to hit hypothesis testing, and make sure you hit proportion 1 sample. So hypothesis testing, proportion 1 sample. Now, when you type this in, they actually want the alternative hypothesis. So this is H of A. So you can type in the population proportion is greater than the claim because we want it bigger than 0.5. Our significance level, since it wasn't given, is going to be 0.05. Our claim proportion is we want it bigger than 50%, so 0.5. Our sample size is N. And our number of successes was 545 of them said, no, they don't like this. All right, so what this says over here, our sample proportion is 0.54. Our test statistic, we need this, is 2.5. Our critical Z is 1.6, our p-value, and our confidence interval. We will use all of these at some point, so we need almost all of this output. All right, step 1. Now there's 8 steps you have to follow. The original claim is that most consumers are uncomfortable with drone deliveries, and that claim can be expressed, so we said that's P is greater than 0.5. That was our H sub A. All right, the opposite is P is less than or equal to 0.5. Now when we're doing this, we have to remember that our null hypothesis is the one that contains the equal. So our null hypothesis is P equals 0.5, and this is H1 or HA, whatever you want. The significance level we have to select is 0.05. Okay, now we have to test your claim about the population proportion. So since it's population proportion, it's our z-score. Our sample statistic p hat is relevant to this test. So we're going to use a test statistic, and that gave us 2.55. That was from StatDisk. All right, now what we're going to do, okay, this hypothesis test is right-tailed because it said it had to be greater than, right? So it's to the right. That's why it's a right-tailed. If it was less than, it would be left-tailed. And sometimes it's two-tailed, like in the middle of. All right, we have our test statistic, which is 2.55. That's right here. That's here on our normal graph. So we draw this 2.55. We're kind of guessing. That's where our z-score is. Now, we get a p-value of 0.0054. That's over here. Okay, the p-value of 0.0054 is less than or equal to the significance level of 0.05. We reject the null. So this says since 0.0054 is less than 0.05, that we reject the null, which means our alternative is correct. Since we rejected the null, the alternative hypothesis is P is greater than 0.5. What that means is that over half of the population does not like to get deliveries from drones. Okay, now let's do the p-value method. 1 through 5 are the same, but now when we look at this, we look at StatDisk, we had z equals 2.55 like before. Okay, now we look at the critical value from StatDisk, which was 1.645 right here. So this is our critical value. Anything that's in this region right here, it means we reject the null. All right, so if it's in this region, that's where our test statistics falls, we reject the null. The null is false. If it falls over here, then we keep the null, or we fail to reject the null. All right, so when we look here, our 2.55 is to the right of 1.645, which is in our rejection region. So we reject the null. It gives you the same thing as we did with the p-value, or the test statistic. All right, last is the confidence interval. All right, so we have already looked at this actually. Okay, can be calculated by hand using your 90% and your p-hat, but if you looked at StatDisk, it was already done for us. If you looked at the bottom, we had 0.514 is less than p is less than 0.566. So this is our range that this has to fall. Now when we say this is greater than 0.5, so we are 90% confident that the limits of 0.51 and 0.56 contain the true value of p. And if you look, 0.5 is not in our range, therefore it cannot be 50%, and that's why we rejected the null. It gives us the same results. All right, to find the number of success, we can use StatDisk for hypothesis testing. You must enter the sample size, n, and the number of success, x, like we just did. All right. In real applications, the sample proportion is given instead of x. Okay, the number of success x can still be found by taking n times the sample proportion. It doesn't matter, it still works. Okay, you considered your data. Example, if you are dealing with people, your answer must be rounded up. So like if it comes up with 106.1 people, We have to round up to 107, otherwise we will be underestimating because you can't have part of a person. So make sure you look at your data and what kind of numbers you should get. All right, I would like you to pause and do this one. Make sure you're following all the steps. Okay, when you did this to find your number of successes, you had to take your total times your percentage, and you get 5587.7, but this is talking about people. You can't have a part of a person, so you have to round up to 5,588 people. I hope you did well. All right, the next one is fewer than 30% of the adults have sleepwalk. So you must test this. I want you to follow all 8 steps and see if you can get this done. So pause and try this one. All right, I hope you did well. The first thing you had to do is check the requirements. We had a simple random sample. The 4 requirements for binomial were met, and they sleepwalk is greater than 5, and they don't sleepwalk is also greater than 5. So requirements are satisfied. Hypothesis testing, we want to know there's fewer than 30% adults, so P has to be less than 30. Okay, the opposite is greater than or equal to 30, so your null should have been P equals 30, and your alternative is P is less than 0.3, or 30. Sorry, it doesn't have to be 0.3. Okay, significant level is 0.05, that's what we chose, and your population proportion is what we're finding. So here we go to P is less than the claim. We have a significance level is 0.05, our claim is 0.30, n equals 19,136, and the number that sleepwalk was 5,588. We found that on the other page. When you type that into StatDisk, these were your results over here. Now when you look at this, you look at your p-value, which is 0.00797, which is less than 0.05, which says we reject the null. If you look over here, we can also use our critical value. We had a negative 1.69, and the negative 2.4 was in the rejection region. So this is the critical one. This one here is the p-value. We need to use both just to check ourselves. So we conclude there's sufficient evidence to support the claim that less than 30% of adults sleepwalk. The other thing we could look at was a confidence interval. It was a 90% confidence interval between 0.28 is less than P, which is less than 0.29. This says we're 90% confident that proportion of adults who sleepwalk is between 28 and 29%. This is less than 30, so that also holds true, since we said they were less than 30 to go. All right, so we just explained this here above in the last statement. Exact methods for testing the claim. We have a left tail, a right tail, and a two tail. So left tail is when it's fewer. Right tail is when there's more. Two tail is twice the smaller. So in other words, we have both sides. So left tail, right tail, two tail. We've already talked about that a little. Okay, the exact method of testing, method of gender selection is what we're doing now. We have 10 randomly selected couples treated with a method. They each have a baby. 9 of the babies are girls. Use a 0.05 significance level to test the claim that with this method, the probability of baby girl is greater than 0.75. So we want to see if this is significant or not. So let's check our requirements. We have a normal distribution, okay, described in part 1, everybody's things, and P is greater than 5 and Q is greater than 5. But NQ equals 10 times 0.5, which is 2.5. So the requirement's violated. The problem is the exact method has only the requirement of being a simple random sample and satisfying binomial. And this it does. So these two requirements are still satisfied. So even though we don't have the 5, we're still good. The 10 is just too small of a population to do this with. Okay, this time it equals 0.75 for our null. Our alternative is greater than 0.75 because we would have more than 0.75% of having a baby girl. Okay, we're going to use StatDisk. So type these into your thing. 0.75 is what you want. We're going to use a right tail t-test because it has to be greater than. 9 or more successes among 10 trials. So stat disk, go to enter your data. X equals 9 gives us P9. Sometimes you may want all the values. So a lot of times we don't enter in the X. Okay, now let's look at the headings here. So we got 10 trials, 0.75. So we're going to go down to 9 here because this is what we're looking at. And it says 9 or greater is 0.244042. You're looking right here is the probability that this will happen. So because 9 or more, we want the last column. And we've already read that out. So the p-value is high, so we fail to reject the null hypothesis. So what this is saying is there's not sufficient evidence to support the claim that with gender selection method, the probability of a girl is greater than 0.75. It's probably because our sample size is too small. And it's hard to get that done. All right, with the exact method, the actual probability of type 1 error is less than or equal to alpha, and which is the desired probability of a type 1 error. Here, let's go down here and show you what we're talking about. All right, pause and try yours. All right, I hope you did a good job on your hypothesis testing. So we have alpha is 0.05, we have our null and our alternative. We want to know 61 is greater than, so we plug that into your stat disk. You got 0.002539. 0.002 is less than 0.05, so you reject the null. So your statement should have been, there is sufficient evidence to support the claim that among car occupants killed by airbags, the majority were improperly belted. I hope you did good. Good luck on your homework, and make sure you post questions if you have any.